In this example, we are given a partial sum for a geometric series, and our task is to find the value of n. So how many terms were added together to get to this partial sum. So to start here, I'm going to use our sum formula, but we're going to work backwards. So I know S sub n, what I'm searching for is the n value. And so to use this formula, I have my first term, so I have that taken care of, but I need to know r. So I'm going to take 100 divided by 60. I get 1.66666 repeating. I take 60 divided by 36. Same thing, I get 1.666 repeating. And so I'm going to go ahead and convert that to a fraction, which would just be 5/3. All right, so from here, I'm going to set this equal to my sum formula. And so we will have 41,291 will equal our first term 36 times 1 minus our common ratio 5/3 to the nth divided by 1 minus 5/3. Okay, so from here I'm going to start by dividing both sides by 36. And we'll see if we get a pretty answer. If we don't, I'll probably leave it as a fraction. So I will just leave this as a fraction just to make sure that I don't have any answers off at the end. So then I'll have 1 minus 5/3 to the nth power. This one we could think of as 3/3. 3/3 minus 5/3 will give us a negative 2/3. Now to get rid of this annoying negative 2/3, I can multiply both sides by negative 2/3 to get out of the denominator. So I'm going to multiply my numerator by negative 2. And I'm going to multiply my denominator by 3. And so I will end up getting negative 82,582 divided by 108 will be equal to 1 minus 5/3 to the nth power. From here I can subtract over 1. And so again, I'm just going to leave this as an ugly fraction for now to keep everything exact. So I have this fraction minus 1. Oops, that should just be 108 minus 1 equal to negative 5/3 to the nth. Okay. We're close to getting to n, but in my next step, I'm going to go ahead and subtract this one as a part of this fraction. I'm going to go ahead and make this an ugly decimal, but just make sure I keep it in my calculator. And then I'm going to divide both sides by this negative, to make this a positive 5/3 to the nth power. So I'm going to take this negative 82,000 number, divide that by 108, and then subtract 1. Then in the same step, I'm going to divide by the negative. So I'm going to be left with 765.648 roughly will be equal to a positive now 5/3 to the nth. From here, I know I need to solve for n, and it's up in the exponent, so I need to take the log of both sides of the equation. And when I do that, I can bring my n out front. So I'll have n times the log of positive 5/3 is equal to the log of this number, which we know is rounded. My last step to solve for n would be to divide both sides by the log of 5/3. So I'm going to go ahead and finish this in my calculator. I know that this number is now positive since I divided that by negative 1. We're going to take the log of that entire number, and we are going to divide that by the log of 5/3. And so I end up getting something really, really close to 13, but keep in mind that the answer, the partial sum, was an approximate answer. So if we would have had more of that answer, this probably would have been a perfect 13. So that means that we had to find the first 13 terms and add them together to get this partial sum. One thing you'll want to keep in mind is if you wouldn't have turned this into an exact fraction right away, this number would have been even further from 13, and it may have not been clear what n is.